Okay, in this video, we're going to be talking about estimating crowds. And as we're going through the video, let me encourage you to either rewind, pause, work on some problems as you go through it, just in case if I'm going too fast or if you need to take any type of notes. So let's go and get started talking about estimating crowds. Now, a question that we have seen a lot before, or maybe have seen at least once regarding some sort of prize or something, is guessing how many jelly beans are in a jar. Now, in reality, the likelihood is that we'll never get a full guess on how many jelly beans unless we take them out and we count them individually. So what we're going to have to do is start estimating. So if that doesn't seem challenging enough to guess how many jelly beans are in the jar, if I was to say, what about a room full of jelly beans? Or maybe not so much jelly beans, but how about people in a crowd, as you can see on the picture here. All right, so the question that we're going to pose today, or in this video, is this one right here, and that is, how can you find an accurate estimation in a situation where you will not be able to get an exact number? So, like, for example, let me go back to this picture here. Here you have, in Washington, D.C., you see the White House. I believe this is the inauguration of Lyndon Johnson. As you can see, there are so many people in the crowd. In reality, we will never get an exact number of how many people are in the crowd. We're going to have to get an estimation. And so we're going to talk about how do we get the best estimation in this situation. All right. Now, the first thing we're going to do is create a proportion. Now, a proportion is nothing more than a ratio comparing something that basically it's comparing a small little area to a big crowd as this. Now I use an example of this little square and this large size. Now this crowd here you will never be able to get an accurate estimation, but this little square here you'll be able to get an accurate picture. So like for example, let's say if I measure this out and this side is 5 feet by 5 feet. I know it doesn't look like that because the picture's kind of distorted a little bit, but it's 5 feet by 5 feet. So let's say if I started putting people in a 5 foot by 5 foot square. Okay, and so let's say if I just kept on trying to fill up as many people as I can put in this square, and I'm just going to go ahead and stop at, I believe this is 12. So let's say in a 5 by 5 foot square, I can fit 12 people. Now I'm writing with my mouse, so it may be a little a little crazy the writing here. So what I'm going to do is I'm going to say, okay, this is my ratio, 12 people in a 5 by foot square. And so the next thing I'm going to do is what are my dimensions of my crowd? Let's say this way was, I don't know, 100 feet. And this one right here is going to be, let's just say that is, well, let's keep it very simple. Let's just say it's a 100 feet. Okay, this is also 100 feet. So I have a 100 foot by 100 foot space that I'm trying to get a number of people, get a number of how many people are in here. So here's what I'm going to do. I'm going to create what is called a proportion. And so I'm going to take this information here that I am highlighting or outlining in green. I am going to create a proportion. I'm going to say 12 people was able to fit into a 25 square foot space. Now, how did you get square feet? I just found the area of this times this. 5 times 5 is 25. The next thing I'm going to do is I'm going to figure out how many people can fit in this 100 by 100 foot space. So here's your situation. The top of your ratios represent how many people you have, and the bottom of the fractions is the amount of area of the space that you're dealing with. So here you're going to go back to your algebra skills and you're going to cross multiply. You're going to multiply 25 times x and then 12 times 10,000. And your next step will be 25x times 12,000, and we're going to divide by 25 because that's what we do in algebra. And this right here, by dividing, we're going to figure out how many people will be in this 100 by 100 foot. I'm sorry, that was 120,000. You guys are probably screaming at the computer because I was getting that wrong. And my answer is 4,800 people. All right, 4,800 people. Okay, that's how you figure it out. Okay. Okay, now what we're going to do is we're going to make it a little more of an estimation here, because here's what happens. Let's say, and let's go back all the way up to this square here. You were able to fit 12 people in the square. Now, someone might say, hey, I can fit more people in my square. Okay, 12 people is not, I can fit more, or maybe I can fit less. So what happens is this 4,800 people is going to be off a little bit. So let's say, like, for example, let's say if you're able to put one more person in your square. So you were able to put one more person in your square. Here it is. So this 12 goes to 13, and everything's going to change. Okay? So we're going to create this equation based upon um, just making an estimation. And let me explain, let me kind of show you what I mean, rather than wasting time explaining it. So here we go. We're going to go all the way back up here to my 5 by 5 foot square. And in my square here, rather than actually putting a whole bunch of people in here, I'm just going to put the big E. Okay? And now E stands for my estimation, which means this is my estimation of how many people can fit in a 5 by 5 square. Now, I don't know exactly how many people there are. I'm just going to say it's my estimation. There's my 5 by 5. So when I create my proportion, what I'm going to do is, rather than putting a number of people in here, I'm just going to put the letter E, which means my estimation. And let me show you exactly how to set it up. You would put E over 25 is equal to X over the space, which I believe was 10,000. Okay, we're going to cross multiply. And so when we cross multiply, we're going to get 10,000 E is equal to 25X. And then we are still solving for X here. So we're going to divide by 25 here. And so that's going to be X is equal to 400 E. Now, here's where the E comes into play. And remember, this is my estimation. So let's go all the way back up to your square. Let's say if you were able to fit, in your estimation, you were able to fit, I don't know, let's just say 20 people. 20 people in your 5 by 5 square. So what you're going to do is you're going to take that 20 people and then you are going to plug it in for E. So now it would be 400 times 20, and that's going to give you a total of 8,000 people based upon your estimation. And the reason why we leave it in terms of E as opposed to solving it like what we just started with is because everybody's estimation is going to be different. And so using a 5 by 5 square, let's say someone else was going to be able to say, hey, I couldn't fit 20 people in my square, but I was able to fit 17. So if I was going to fit 17, then that person's estimation will be different, because this will now be 17 that we're multiplying by 400. And that's going to give you a different answer. All right, let's try our next question. And we're going to be solving terms of E. It says how many students can fit in a room that is a 20 by 30 feet, or that is 20 by 30. Now it says in our directions, use a 10 by 10 square to compare. Solve in terms of E. So once again, we're going to be solving in terms of E, which means our estimation. So we're going to put E over the little square that we're using, which is 100, is equal to X over, I believe that will be 600. We're going to cross multiply. When we do, we get 600 E is equal to 100X. And then when we solve, we get X is equal to 6E. Now once again, that E is basically there for our estimation. So it looks like GE, but it's actually 6E. So if I was able, once again, if I could fit 50 people in my square here, that means it'll be 6 times E. That means I'd put that 50 there. So that would be a total of 300 people. Okay? And that's how you do it. That's how you solve for E. If you have any questions, let me know.